So Java is one of the programming language and a platform. What is a program? A program is nothing but a set of instructions where you can execute them. If you execute, you will get output. Like if you do 2 plus 3, you will get output 5, right? So that executable statements you will write. Those executable statements are called a program. That's why Java is a programming language and a platform also. What is a platform? Any hardware or software environment. In that environment, you can run the program. Whatever the executable statements you are writing, those can be executed on that environment. That is called platform. So Java has its own platform, runtime environment and API is there. That's why Java is a platform also. And first Java was invented by Sun Microsystem company employees. So there are 3 people are there. The first person is James Bosley. He is the father of this Java. So, and later 2 more people joined with him. Those are Mike Sheridan, Patrick Norton. These are the 3 people developed the Java, but it came from C++ only, C and C++. And later, so they all 3 worked, and the purpose is a different level it went. The main purpose of this Java development is remote control access purpose. Our TV remote setup boxes, remote control access purpose, they want to develop some logics. That purpose they developed this, but later the usage level went to different areas. So we'll see where people are using this Java in all the places. And that's what the history of Java. First, they have given a green talk name for the Java with a .gt extension for the file. Then they changed again green talk to oak name they are given, but oak has a so another company name also there, and also poetry name in many countries, right? So they don't want confusion on that also. Again, they change it to Java finally. So that they maintain, and so it's continuing. But first version of Java released to the market by Sun Microsystem in 1995. The first version of Java released to the market in 1995. Now, Sun Microsystem is acquired by Oracle company. So there is no Sun Microsystem now. So till Java 7, Sun Microsystem released all the new versions. Till Java 7, Java 1 to Java 7. So during that time, Java 8 is released by Oracle company. So Oracle took over this Sun Microsystem, and now it's a product of Oracle. Java is a product of Oracle now. So there is no Sun Microsystem at all. And Oracle released a lot of releases. Every 6 months, one release they are doing. Every 6 months. You can see every 6 months there is a release. So March and September, they will do the release. Now Java 18 is already rolled out. But we don't need Java 18 for our automation purpose. We don't need to bother about that. So Java 11 or Java 8 is more than enough for us. So now companies also rolling out to Java 11 only still. So Java 8, Java 11, any one is fine for us. Or you want the latest, you can use latest also. But there are some restrictions on the other tools. That's why we are using Java 8 or Java 11. So anyone is fine for us. So I'll show you how to install also. Don't worry about that. So this is all a history. I already explained this, where this Java is used. So Java is used widely in the desktop applications. Like you see your PDF, right? Acrobat Reader, media player, antivirus softwares. This kind of applications are developed by Java. That's a first place where Java is used. And then second, web applications. There are so many web applications will be there, but I listed out one is IRCTC website in India, train ticket booking, right? So that is one website fully developed by Java. And enterprise applications such as banking applications. So banking applications also widely use this Java J2E advanced topics. And mobile to application development, also Java is used widely. Embedded systems, smart card design, and robotics, games applications, all these places Java is used widely. So these are all the some of the areas where Java is used, so widely using. So Sun Microsystem done a survey, 3 billion devices are using Java at that time. But now the Java scope is increased. And what are the different types of Java applications in the general IT? So we have 4 types of Java applications. We have standalone application, web applications, enterprise application, and mobile applications. So in the generally we'll see these kind of applications in the market also. What is standalone application? Standalone application are desktop applications, are Windows based applications. How you can recognize this? Let me show you. There is a exe file in your so when you download from websites, there will be exe file concept. If you find exe file, see these are all exe files. So Zoom or any desk, these are exe files. If you double click on this exe file, the window will open. Right? The window will open. This is a window will open to you. This is the Windows based application. You don't need any internet for this to open, right? So that's the kind of Windows based application means. So such kind of application so are created using Java technologies. And the examples for this standalone application is media player, antivirus, Acrobat Reader. These are the some of the examples. Okay, what technologies are used to develop such kind of Windows-based applications? This is the technologies. AWT and Swing are the Java technologies used to create the standalone applications. AWT and Swing is the some kind of Java technologies. So these technologies are used to develop the standalone application. And web applications. So web applications runs on server side and they will run on internet only. If you have internet only, web application will open on the browser. You will open on the browser and you can use those web applications. But so what technologies are used to develop web applications? All Java concepts like servlet, JSP, struts, Spring, Hibernate, JSF. So these technologies are used to build the web applications. And enterprise applications, that means bigger applications, like you can see Amazon, all banking applications. Such kind of applications can be developed using latest GTU technologies. Java enterprise edition is used there, like because you need more load balancing, high level security, and you have to maintain multiple users. So when they are hitting your application, you need to sustain that load. So that such kind of bigger applications you can develop using latest Java technologies like Spring Boot, web services. So all these latest technologies are applied in this enterprise application development. So Java Beans, enterprise Java Beans are used in this enterprise application development. So we have a mobile application development. So Java ME is used for creating the mobile applications. So these are all different types of applications are developed by Java technologies. So these are all Java technologies. So this for just for your information, application development purpose, but we are not going to use. For us, just a basic core Java is enough for our automation. We don't need to learn all these modules. You don't need to learn all these modules for our automation. So what are the different Java versions and editions are there? There are 4 types of editions and platforms are there. Java SE, Java Standard Edition. This is the main edition, core edition. This is enough for us. So it is a Java programming platform. Standard edition means Java programming platform. It includes Java programming APIs such as java.lang, java.io, java.net, java.util, java.sql, java.math. So all these are packages. Packages means generally package means what? A collection of a group of similar kind of things, right? That's a package. So those many built-in packages are available in this when you install Java Standard Edition in your system. Automatically you will get them. So all these packages contains different topics, core topics like OOPs, object-oriented programming concepts, strings, how to handle with the strings. So you can work with the strings also, regular expressions, exceptions, inner classes, multi-threading, input-output file handlings, networking concepts, AWT, swing, reflection, collection, all these basic topics you can find in this standard edition. That means if you install Java's SE, that's good enough for us. So you don't need to worry about other latest technologies. So for us, Java Standard Edition is more than enough. Okay, that's a Java Standard Edition. What topics are there and what are the things we are going to learn? But in this, all we don't need. We are not going to work on these areas. We don't need multi-threading. We don't need inner classes. We don't need regular expressions and AWT swing reflection. We don't need. We just need OOPs, basics of Java, and collections, string handling, and file handling, how to handle the files, how to work with collection, how to work with the strings. These are the topics important for us. We are not bothering about other, so these technologies also, these topics, we won't learn this, not required for the Selenium. That's why, so I'm saying basics are very important and some advanced. These are all advanced topics. OOPs, string handling, then exception handling, collections, file handling. These are the advanced topics. Okay. So that comes under all Java Standard Edition. Java Enterprise Edition, so which is going to have a lot of new technologies. Basically, to develop your enterprise applications or web applications, you have many topics like, basically this will come on top of this standard edition only. So Java Enterprise Edition built on top of standard edition. You are installing Java Enterprise Edition means you have a standard edition plus the extra modules like this: servlets, JSPs, web services, EJB, JPA, all these new topics also you will get. This is the J2E, we call this. So Java EE Enterprise Edition, right? So this is the another edition to develop web and enterprise applications. You will use this Java EE. So there is a Java ME, that means micro edition. Micro edition means which is mainly used to develop mobile applications. So based on your development, you can take that version, you can install on your machine. Okay. JavaFX. What is JavaFX means? And JavaFX means it's a APIs you can develop with this JavaFX. APIs you can develop APIs means I'll tell you this now. So system to system interaction can be done with the APIs. That APIs we can develop with this last edition, the JavaFX. Okay, so these are the different editions based on your requirement you can install in your system. So basically Java installation. So these are the Java versions. 1995 first version is released, and then these are the different timings, and Java 8 is released by Oracle. See, March 2014, Java is released by Oracle. So till this, my Sun Microsystem was there. So this is the Java SE8. And another thing is, so Java 17, 18 also ready. 18 is released in March. So already rolled out 18 also. So this is all the basic history of Java. And let's see, every programming language has some features. What they will do, some features will be there. That features we'll learn. So what are the features? Let's see that. Java is a very simple programming language because it has taken from C++ language, C and C++. Even if you don't know, don't bother about that. So in C++, there are some complicated topics will be there. Those complicated topics are avoided in the Java. That it will be easy to understand and easy to learn, and it's a simple and clean programming language. So these are the some based on the C++ syntax only Java is created. Java is designed. Java has removed many complicated topics like pointers concept one, operator overloading another one. So all these topics are removed in Java. So those are a bit complex. That's why they removed here. No need of any pointers concept in the Java. And another one is automatic garbage collection will happen if there is any unused objects are available in the system. So what will happen if there is unused objects? Unnecessarily memory issues will come, right? Performance issues. If more memory is there, more memory occupied, the application won't perform properly, right? So that kind of unused objects are there. The garbage collector is there, default garbage collector, that will be cleaned up and it's free of the memory. That's another advantage with the Java. So that's why it's a very simple programming language. And second one, Java is an object-oriented programming language. So objects means everything in Java is an object. Object is nothing but a physical entity that you can see that, like a computer, table, mobile, car, house, anything, right? That's a physical entity, physical object. You can see that. So every object has a purpose. So that purpose will be different. Every object purpose is different. How you can deal with these objects? So what is the behavior of that object? What is the state of that object? So you want that object behavior and state is explained by this object-oriented concept. So real-world entities we can represent in the software by these object-oriented concepts. So object-oriented programming language is nothing but it's an approach or a framework where you will follow certain guidelines and rules. so that you can maintain your code very easily and you can avoid the duplicate code. A lot of advantages are there. You can secure the data also. So that's why if you follow certain guidelines and procedures, you can maintain all the data securely and you can avoid the duplicate code. You can reuse the code. You can abstract the code. So all this happens with these OOPS concepts. So this is an advanced topic. Anyway, I'll explain. But basic idea I'm giving, what is object-oriented. So, but very beginning, I'm going to give what is object, what is class. Then later we are going to learn inheritance, polymorphism, abstraction, encapsulation. So these topics we'll learn after basics only. 1 month after we are going to learn these 3, 4, 5, 6. But these things very beginning. So next third class onwards, we're going to learn these things. What is a class? What is object? You will come to know. So, and that's the object-oriented concepts. And Java is a platform independent programming language. Why independent programming language? So that means what is meant by independent? It can run on any operating system like a MacBook, Windows, and Linux operating systems. You can run your Java code without modification. You have written some program. Same program can be run on any operating system. So how it is possible? So let me explain this so in detail so that you will get a better idea. So basically, any programming language you take, first, so the code will be written. Let me take. I'll go to one notepad. Let me drag completely so that you will get a fair idea here. Any how your program will execute. So in the any computer. So this is the plan, but I'm giving here a very high level on Java. But so and any computer, the code will execute like this only. Okay, so code will execute like this, and you have these components. But these components also in the computer inside only. But except only this code we are writing, and these programs how we are going to write. So this is the called. Let me name all this. This is a program, Java program you're writing. Simple program I'm writing here, okay? And that is this. Bit more. Yes, we need more length for this. Okay. So let's write this Java program. I'm just writing a very small program, okay? Very, very small program. So what I'm going to do, public class test. So what I'm going to do is very basic program I'm writing here. I want to sum any two numbers, okay? That's a simple program I'm writing. Public static void main. So this is the simple program I'm writing. This is the main method where your code will execute here, okay? So all your code will be executed here. So here, for example, I want to sum two numbers. So what I will do, int sum equal to a plus b. Suppose I will declare a value, b value here. Int a equal to 5, b equal to 10. So like this, I stored the data in the variable and I'm summing up, and this value I'm printing. So how to print? You have to write system dot out dot println. Or simply you want to print anything, you will use this system.out.println. So sum, you can print a sum, directly you can print sum. Okay, so this is a very simple program you are writing. Now this is a human readable program, right? The human, you can read it, right? You can read it, but the computer doesn't understand this, right? This one, the human readable programming language cannot be understood by computer. So then what we are going to do is this a human readable program. Instructions, right? Human readable instructions are statements. But computer doesn't understand. The computer, your computer doesn't understand that. So for computer, you have to give machine understandable code. Machine understandable code you have to give. Machine understandable code. What is this machine understandable code? So that is called bytecode. The bytecode you have to give it to your machine code for the computer. So here you have a so one more layer will be there, that is a JVM we call this. So these are all part of this JVM only, but I'm showing separately. So this is the JVM we call this. So JVM we call inside your computer, JVM will be there. When you install Java, this JVM will automatically will come there. So this is the Java virtual machine. JVM means Java virtual machine. So the program execution will happen in this module only, in this machine only. Basically, it's a machine. But how this will be converted into machine understandable code? See, first, what happens is this entire code will be converted into bytecode by the compiler, and the bytecode will be supplied to this, and then in this JVM inside, this component is there, then you will get output here. So this is how it is happening. So what you call this module? What you call this module? So this is called compiler, and this is called interpreter. So basically what this compiler will do, it will take the human readable code, that means all plain English code, and this is called test.java. Basically this file format is your class name. There is a class keyword after some keyword is there, right? Tester. That is your file name. So what is the file, how it will save this one? Whatever the class keyword after is there, the test.java. .java is the extension for Java file. .java is the extension for Java file. Now what will happen is this plain English code will be converted into bytecode format. Converted into bytecode by the compiler. So what is the bytecode? 1000010 and 1011. This is the all bytecode. So this every statement will be converted into this bytecode. That bytecode will store in one file. That file is test.class. So test.class file will generate apart from test.java. So who will generate this test.class? This compiler. What is the compiler name in Java? The compiler name is JavaC. This is the compiler name. So JavaC is the tool. This tool will convert the plain English code into this bytecode format. So who is doing this? The compiler will do that. So this bytecode is available where this will store in the .class file one generate. It will generate the .class file. Automatically, all this code will be converted into bytecode here. So this bytecode will be supplied to JVM by the JVM components. Then the interpreter will take this bytecode stream, the bytecode stream line by line, and execute. This the execution is done by interpreter. Execute each bytecode stream. Then the output will be printed for you. So output will print for you. So sum up 5 plus 10, 15 will store in this sum, and that sum will print for you in the console. This is how code will execute in any computer. This is the process. Okay, but I have given in the Java programming, but other programming languages also same structure. Clear? Any questions here? So this is the machine understandable code here.
So like now in the compiler you said like a tester class, it's create the another file and it converts all into the bytes. But when you send to the JVM, what exactly they're going to do?
Same bytecode. This bytecode, this file only will be given to JVM.
Okay, but what will happen there? Because the interpreter, like their executes.
Interpreter will take, interpreter will take each bytecode stream, right? This bytecode stream will take line by line and executes that.
But in Java machine, JVM, what will happen? Like in that.
That I'll give you clarity. That I'll give you. This interpreter is also component of JVM.
Okay.
But this test.class file also loaded into JVM by JVM components. So there is a JVM architecture separate topic. I'll give you there. As of now, understand here. So the compiler will convert your plain English statements into bytecode format. That bytecode will be there in the test.class file. This test.class file will be supplied to JVM, and JVM component will execute each bytecode stream. Then it will produce the output to you. This is how your statements will execute in the computer. Is it clear? Any questions on this diagram? Okay, so no questions. I'll just moving on. Let's move on to this one. See this class file, right? That dot class file. That dot class file will be loaded into JVMs. Every class file is going to load it to based on which computer you are running, like Mac, so Windows, or Linux. But each operating system JVM is different. Then how it is common class file? The bytecode is common to all the JVMs. That's why it can be run on any operating system without any issues. That's why you will write the Java program once and you can run anywhere. So write once, run anywhere. That's the concept of Java. So because of this bytecode only, it is a platform independent. Because that bytecode is common to all JVMs. Even the JVMs are different. JVM structures are different. So based on the operating system, JVM structure is different. But because of this bytecode is common to all the JVMs, so that your Java code will run on any operating system without any code changes. That it's a common bytecode is common to all JVMs, and so you can run from any operating system. So that's why it's a platform independent programming language. Java is a platform independent. Independent means it doesn't depend on the architecture, it doesn't depend on any processor, anything, everywhere it will run. That's why Java is a platform independent, architecture neutral, and also portable. Portable means what? You can carry forward the same bytecode to different platforms also. That's why key features I'm explaining with this concept only. So that's a platform independent, architecture neutral. It doesn't depend on the what architecture is 32-bit, 64-bit. It doesn't depend on that. But anywhere it will run. Which processor, which hardware you are running, it doesn't matter for that. Any hardware, any processor, it will take and it will run your program. Okay, so that's why it's the architecture neutral, platform independent, and a portable language. Okay, so any questions before jumping on to the next feature? It is a secure programming language. So why it is a secure programming language is basically there is no pointers concept in Java. That's why you can develop secure and virus-free systems with the Java programming language. And why it is secure means, let me explain you. When you see the C++ application, it directly running on the operating system level. But when you see here, see operating system level inside one more layer, that is JVM layer. JVM layer inside your Java code executes. That's the difference between C++ application and Java application. So there is a layers, multiple layers, right? So you have one more layer here, production, right? More production. So you will have OS inside your JVM layer. JVM inside your Java code will execute. First compilation will happen, then execution will happen. So you need to understand two ways here, compilation and execution. So as in the diagram I have shown you, first compiles the code. Compilation time, what will happen? The plain English words will be converted into bytecode format that will store in the dot class file. The dot class file only will be given to JVM. So that's why it is a more secured. So who will load this dot class files? So this is the component of JVM. Class loader is the one of the component of JVM that will load all class files into JVM. Java virtual machine inside, it will load dynamically, it will load, and once that is loaded and it will go and store in the memories, then bytecode verifier will be there. It will verify the bytecode stream is proper or not. Then security manager, while accessing the resources, reading and writing the data properly or not, it will check security manager. So that's why all this is a secure programming language overall, because of more security, more layers are there. And even you can develop the other security layers also, like SSL and JAS, cryptography. These are the famous security layers in the application development. But inbuilt security will be there for Java. If you want to add extra, these extra SSL means secure socket layer, JAS, Java side security layer, this one, cryptography, another security layers. If you want, you can include them also in this Java applications. That's a secured programming language. So Java is a robust programming language. Why robust? Robust means very strong programming language, right? Why it is a strong? Because it's a strong memory management is there. Dynamic memory management. You don't need to allocate. Automatically it will store in the memory. So when you storing some data, it will go to the respective memory partition. And pointers concept is not there, so security problems won't arise. Automatic garbage collection happens in Java. In the JVM system, garbage collector keep running. If any unused objects are found, it will delete them from the memory. That's the garbage collector responsibility. And exception handling, runtime, you are getting some exceptions. Your program is not continuing. That you can handle with exception handling. So that till last line of code also you can execute with this concept. And also you will find why it has stopped. Why particular line is failed, you will come to know with this exception. And type checking mechanism also you can find. So all these points makes Java very, very strong. So as I told you, architecture neutral, I covered that. Portable language, I covered. And high performance language. High performance language means because it's a interpreted language and already Java developed some code. That code is very close to your code and it will take, so your code and interpreted code and executes very fast. That's why high performance output it will give it to you. And you can develop distributed applications. Basically, you can develop distributed applications with Java new technologies like Java Beans, Spring Boot, web services. You can develop and you can access from anywhere if you have internet. So, and last one is multi-threaded applications. Multi-threaded applications. Every web application is a multi-thread application. So thread is nothing but a separate program executing concurrently. So we can write Java programs that deal with many tasks at once by defining multiple threads. Suppose you assume that you are accessing a video of our YouTube channel. N number of people can access same video. How is it possible? One resource is there. Same resource is accessed by 10 people. So 10 threads will create for each person. Each thread is for one person, same resource. Memory is same, but multiple people are able to access same thing. So how is it possible? Is because of multi-threading concept. So one resource can be accessed by multiple resources, multiple people because of this threading concept. Basically, what does this? It shares the common memory area. So one memory and it will be shared by all threads. And it will serve for you, your purpose. So that's why this multi-threading concept mainly implemented for any web application and multimedia applications. This concept is very important that you have in the Java. So every programming language has this multi-threading concept and a dynamic programming language. So based on the requirement, the classes will be loaded automatically. On demand, which class you want, it will load and it will execute your program. So that's all the features of Java. And so tomorrow's class, I'll explain